This is a lecture in the Foundation Degree in Building Services and Renewable Energy in the Design and Installation Renewable Energy Technologies module. Today we want to have a look at heat pump technologies and an introduction to heat pumps. So first we look at the type of energy that heat pumps extract. And one of the types of energy that a heat pump extracts is what's known as geothermal energy. And basically what geothermal energy, it's thermal energy that's either generated or stored in the earth. So traditionally geothermal energy would be from volcanic or subsurface activity. So the top picture up here, for example, is a power station in Iceland, where there's considerable volcanic activity close to the surface, and in places like Iceland they can actually tap that volcanic activity and drive power stations to generate electricity. So these are quite common feature in places like Iceland. Basically thermal energy is the energy that determines the temperature of matter. So anything that has a temperature will have thermal energy embedded in it. The geothermal energy of the Earth crust originates from the original formation of the planet. So about 20% of the heat of the Earth is generated from the original formation, and then about 80% of the heat of the Earth comes from the radioactive decay of minerals that are contained within the Earth. The geothermal gradient, which is a difference in temperature between the core of the planet and the surface, basically drives a continuous conduction of thermal energy from the source of the heat, i.e. from the planet's core, to the outer surface, basically where we are on the surface of the planet. So there's always a heat coming up from a geothermal activity in the core of the planet. So it's tapping into geothermal energy. There's two means to do it. One is quite direct, where you're tapping into the volcanic activity, and the other way, which we'll look at going through this, is for shallow, sometimes called shallow geothermal or heat pump technology. So a heat pump basically is sometimes called shallow geothermal. There's a bit of a debate in the industry whether a heat pump is actually a geothermal or it actually is just gathering solar radiation from the surface. But it can be sometimes called shallow geothermal or just shallow ground source heat pumps. And basically a heat pump is a device that transfers heat energy from a source to a heat sink against a temperature gradient. So basically what that means is that it'll take heat from the heat source and it'll bring it to somewhere else. It'll concentrate it, or it'll magnify it, it'll intensify it. Heat pumps are designed to move thermal energy opposite to the direction of spontaneous heat flow. So generally heat will always go from somewhere where it's hot to somewhere where it's cold. Conversely, the way a heat pump works is it takes heat from the outside, which in this case is in the garden, a ground source heat pump, and brings it inside at a hotter temperature. So it increases the temperature of the water. A heat pump does use some amount of energy to accomplish the transfer of energy from the heat source to the heat sink. So the heat sink will basically be a hot water cylinder generally in the house, or it could also be internal air heating. So what is a heat pump? Let's see where a heat pump works best. Heat pump, as I say, is sometimes referred to as a geothermal device, but the shallow ground types of heat pump generally work well in most locations in the UK. On the right hand side here you can see sort of a geothermal map of geothermal activity in the UK. So generally most of the UK is a very similar geothermal activity underneath the surface. A few hotspots sort of just south of Scotland, the North Midlands, and down here in the Cornwall direction. Parts of Northern Ireland you can see as well, sort of a nice little hotspot there just around the border regions, and also sort of just up on the tip of the Antrim coast. So what the heat pump does is it extracts heat from either the geological or the environmental surroundings. The geological surroundings basically means from the ground, or the environmental surroundings means sort of like from air. So geological could also be from water. And geothermal energy refers to large scale energy from the earth, but it can also be used to describe small scale ground source heat pumps. So as I say, there's a bit of a debate in the industry as to whether heat pumps are classified as geothermal energy devices, but sometimes you will hear them referred to as that small scale geothermal devices. So, as I say, sometimes called shallow geothermal. So basically that's what a heat pump does. It extracts the heat from your geological or your environmental surroundings, and it transfers it into a heat sink, which will generally be a hot water cylinder within a property. So have a little think for a minute. Do you have a heat pump at your home? Would you have one? Most people say no, they don't, but I would guess most people, if not all people, will have a heat pump already in their home. And basically that would be a fridge. A fridge is basically a heat pump. So the fridge operates by taking the heat that's within the cold space and dumping it out the back of the refrigerator. So it makes it inside, makes it cold, and out the back of your fridge or your freezer, the heat gets dumped, and that's what keeps the fridge cold on the inside. So basically a heat pump is works on the same sort of mechanism as a fridge or a freezer, in that it takes heat from one area and puts it in another area. And basically what a heat pump is just a fridge in reverse. So compressor driven air conditioners and freezers are typical examples of a heat pump, and the term heat pump, however, is more used to apply to heating, ventilation, air conditioning devices that are used for space heating or space cooling applications. So a heat pump can be used both in a heating or a cooling mode. So when a heat pump is used for heating, it employs the same basic principle, refrigeration type cycle that's used by an air conditioner or a fridge, but just works in the opposite direction, releasing the heat into the air conditioned space rather than into the surrounding environment. So it's in this use that heat pumps generally draw heat from the cooler external air or from the ground, and that's where they get their heat from. So there are a number of different types of heat pump currently available on the market, and basically they're differentiated by what they use as their heat source. So what you can have is heat pumps that will extract heat from the ground, heat pumps that will extract heat from the air, or ones that will extract it from water. There's other types as well that can extract heat from sort of waste gas flues, heat from gas flues, etc., like that. But the most ones that would be used in a domestic setting in and around domestic properties would be either from ground, air, or sometimes water. Ground and air would be the two most common ones. And then they're defined by what they output the heat to. So they can either output the heat into hot water and store the heat generated in the hot water cylinder, or it can be output as warm air or cool air as well if the heat pump works in a refrigeration mode cycle. And basically that's the types of heat pump you can have. You can have ground to water, you can have ground to air, you can have air to water, air to air, and water to water or water to air. So these are your heat sources, and these are your heat sinks on the right hand side.